This lesson is more about more definite integrals, and specifically we're going to look at some of the properties of definite integrals. And remember, you can pause this as much as you need to, but you do need to get through the lesson because there is going to be a quiz on this tomorrow. So picture below is the graph of the function f. Find the values of each of the following definite integrals if a value exists, and if it not, explain why. Sorry, I got to give a quick hug. All right. Sorry about that. So we're going to basically try to figure out where this is on the graph, and then we're going to use some geometry to figure out the area of it, because I don't really have a function, I just have a picture. And there's a lot of this. This is a really thing they love to ask on the AP test. So we're going to go from -4 all the way to 2. And we look at the shapes that we have in there. If you notice in here, we have, it looks like we've got all kinds of interesting things. This part in here is a trapezoid. And then I've got a triangle and a triangle. So I'm going to find the area of all of those things. Okay. Just making sure that I'm doing it the way I was supposed to here. Yeah, okay. So the first thing is the area of this trapezoid. So we know the trapezoid is, we divide it by 2. And then we've got to do the first base is length -3. So we're going to actually use the -3. And the second base is length -2. So we're going to use the -2. So we're really adding -2. And then we multiply that by the height, which is this right in here, which would be 3. And then we're going to add that to the area of this little tiny triangle here, which is 1/2 base times height. So the base is 1, and the height is -2. And then we've got this big triangle right here that we have to add it to. So on that one, my base is 2. So we've got 1/2 the base of 2 times a height of 2. All right, so let's do that calculation. So we've got -3 times -2 is -5 times 3/2. This is going to cancel, but I've got a -1. This is going to cancel, so I've got +2. -5 times 3 is -15 halves. And -1 plus -2 is just a +1, but I want it in over 2 worlds, so I'm going to make it 2 halves, so that would make it -13 halves. All right, same picture. We're going to do a different spot. We're going to go from 0 all the way to 3, which means I've got this triangle and this triangle. So I'm going to do area of 2 triangles. So 1/2 the base, which is 2, times the height, which is basically your y value, which is 2. I'm going to add that to this area here, which the base is, so 1/2 the base is 1, and the height of this triangle is -2. So these 2's are going to cancel, so that one's 2. These 2's will cancel. Negative times 1 would be -1. So my area on that one is 1. All right, this time I'm going to go from -1 all the way to +1. So I'm finding the area of this triangle and this triangle. So my base length is 1. So 1/2 times 1 times my height of, of -2. Plus 1/2, this base length is 1, times the height of 2. So these 2's are going to cancel. So we've got -1 here because it's 1 times the -1 that would be left. And those 2's cancel, so +1. So that equals 0. And basically what happened is this area and this area were equal. And we saw that the other day before break, that when the areas are equal there, they end up canceling because one's a positive area and one's a negative area. All right, this is a little bit different. This one is saying that I'm going to integrate f prime. So that means I would get back to f of x. But there's a catch on this, okay? So if a value does not exist, we have to explain why. So if I'm looking at this, and this is actually the graph of f. If I look at trying to take the derivative of that, which would be this, okay? Remember, there's places I can't have a derivative. So if I have a corner or a cusp or an oscillating or a jump, I can't have a derivative. Well, there's a corner right here in the middle, which is in our interval from -4 to 0. So I cannot actually integrate that because the value doesn't exist. So you would want to say something like it does not exist. So it does not exist because f prime is not continuous at x equals -1 as f of x is not differentiable. Okay. So let's try this one. So this time we've got to go from, we've got to go from -1 to 1, but notice I am integrating f prime, not f. So when I integrate f prime, and we don't have a corner in there, so we're good. When I integrate f prime, I get back to f, and I'm going to go from -1 to 1. So fundamental theorem says I plug those in, so I'm going to go f of 1 minus f of -1. Well, I'm not finding areas this time. I'm using the graph to find these y values. So when I go to 1 on my graph, my y value is 2. When I go to -1 on my graph, my y value is -2. Double negative is going to become positive, so that when I integrate it equals 4. All right, let's look at this one. We're going to integrate f prime again. So when we integrate f prime, we get back to f. And the fundamental theorem says I'm going to plug in the 3 first. So f of 3 minus f of 1. And so we're going to read those values off the graph. So I should have really checked to make sure that that works. From 1 to 3 should be fine. All right, so when I put in a 3, I get -2. And when I put in a 1, I get 2. And -2 and -2 is -4. All right, so now what we're going to do is we're going to go through some properties that we have. So the first one is if I integrate from a to a, so a number to itself, what I basically do is when I integrate the f, the way to show that is we could say we get the capital F, and we would really have f of a minus f of a, which is ultimately 0. So a number to itself when we integrate it is always 0. One thing we're allowed to do, and I think we may have saw this before, but is we're allowed to break integrals up if we need to. So if c happens to be between a and b, I can go from a to c of f of x dx, and I can add that to c to b of f of x dx. So I can break it up at a convenient value if I want to. Let's do 4 before we do 3. I think it'll make more sense. This is saying that b is the smaller number. So b is smaller than a. Well, if I have my small number on the top, I can't integrate that way. I always have to integrate with my big one on the top. So the way that we take care of that is we put a negative out in front and we switch their locations. Now, sometimes it's convenient to switch their locations. So that's what this is saying is if I went from A to B and all of a sudden I switch from B to A, what that's going to do to this K is it's going to make it negative. And K is just standing for a constant. We've seen this before. You can take a constant and we're allowed to put it out front. So K from A to B of f of x dx. This one is just saying that we're allowed to break it up into two different integrals if we need to. So we can go from a to b of f of x dx plus or minus from a to b of g of x dx. So this is talking about having an even function. This is somewhere we know that there is y-axis symmetry. And notice it's going from a number to the same number. So if this was, say, negative a and this was a, you'll notice that these areas would actually be the same. So instead of taking the area of the whole thing, a little shortcut is that we can do 2 times the area from 0 to a of f of x dx. Or we can do 2 from negative a to 0 of f of x dx. But if it's an odd function, we have that same thing, and if it's an odd function, meaning it has origin symmetry. So, and it's still going from negative a to a, so if this is negative a, and this is a, and you'll notice that if I looked at these areas, that they'd be the same area, but one would be positive and one negative, so they cancel each other out. So what happens here when you have that odd origin symmetry is that you would get 0. We actually saw that back here in a few, like this one, not that one there. This one here has that origin symmetry. So if you notice that, and notice it went from negative 1 to 1, and when it was odd function with origin symmetry, we could have just said 0. Okay, let's do a couple of these problems. So they're not going to give us a function, they're just going to give us some information about the function. So if we have the integral from 0 to 3 of f of x dx equals 6, and from 3 to 7 of f of x dx equals negative 8, determine the value of each of the following integrals. Use the properties to definite integrals. Explain how you arrived at your answer for each one. Okay, so this first one, the first thing that's wrong is our bigger number is on the bottom. So in order to fix that, I have to put a negative out front, and then I swap the order. So 0 to 3 of f of x dx. Now we know what 0 to 3 is equal to. I can replace that with a 6. So I drop the negative and I replace it with a 6. Oops, sorry. Don't know what's going on here. All right, there we go. Okay, so this one is saying it wants us to go from 0 to 7. I know from 0 to 3, I have 6, and from 3 to 7, I have negative 8. So I'm going to use those two things. So I'm going to break this up into, because remember, I'm allowed to break it into a convenient spot, a convenient C value that's between the A and the B. So I'm going to break it into 3. So 0 to 3 of f of x dx, and I chose that because I know that up here, plus from 3 to 7 of f of x dx. I know I'm allowed to replace this with a 6, and I know I'm allowed to replace this with a negative 8. So my answer is negative 2. Okay, example 9. This is our favorite one of them all. Because when I integrate this, I know I'm going from 3 to 3, that it should be 0. If we wanted to show a little bit more work, we could say that capital F of x is the antiderivative. So we'd have f of 3 minus f of 3, which would definitely be 0. All right, the first thing that's wrong is that those are in the wrong location, and then we are allowed to take that 3 and move it out front. So to flip the location, we make it negative. We put the smaller one on the bottom and the bigger one on the top. Take the 3 and put it out front. And the reason that's good is with the 3 in there, I couldn't substitute in. But here, I know exactly what this part is equal to. It's equal to -8. So I've got -3 times -8, which is 24. All right, this one is 2 separate functions, so we're going to split it up into 2 separate integrals. At the same time I'm splitting it up, I'm going to move this out front. So I've got the integral from 3 to 7 of 2 dx. That's just this part. And then I'm going to add that to the integral from 3 to 7. I'm going to float the 3 out front of f of x dx. All right, when I integrate 2 dx, I know I get 2x, and that's just from our basic integral rules. And we're going to go from 3 to 7. And then when I integrate this, I know the 3 is just going to hang out. This piece I know is equal to -8, so I multiply by -8. This is one they like to put on the multiple choice test, on the AP test. I've got to plug in here, so we've got 2 times 7 minus 2 times 3, and then 3 times 8 is -24. So 14 minus 6 minus 24. And we end up with -16. All right, they're saying that f is an even function, so they're actually telling us that. So we know we could take, because I don't know what -3 to 3 is, but I know what 0 to 3 is. So I know I am allowed to take and double from 0 to 3 of f of x dx. Now I can replace this with the 6. So I've got 2 times 6, which is 12. All right, this time they're telling us it's an odd function, and I've got from -3 to 3. So that means I could split this up into 2 separate integrals. I'm going to do that first because I know I can make that convenient split at 0. So if I go from -3 to 0 of f of x dx, and I'm going to add that to from 0 to 3 of f of x dx. And this is kind of showing the work. I would have probably said, hey, I know those are both the same, and I know this equals 0. But if it's odd, then these 2 areas should actually be the same, but with opposite signs. So this sign here we know has to be +6. And then this sign here we know how it'd have to be the same area, but with an opposite sign because they're the same distance there. So we're going to say it's -6, so it's got to be equal to 0. I would have probably just looked at it and gone from -3 to 3. It's odd. I know it's got to be 0. I don't necessarily need that entire explanation. Okay, so this is where we're going to stop. I'm going to pick up here tomorrow because this part's not in the homework tonight. Please make sure you should have some time left. You need to go in and you need to start the homework. You need to start doing your homework, okay?